Dear friends, in this video we are going to discuss about errors in measurements. All physical measurements are subject to various types of errors. Whatever measurement we are going to take, certainly it will have some errors. It is important to reduce the effect of errors to a minimum. That can be done. In order to know the uncertainty in measurement or to know the deviation from the true value of a measured quantity, it is important to have an idea of the sources of error as well as estimates. So error involved in any measurement may be broadly classified into two categories. One is systematic error, second one is random error. Systematic errors that are not revealed through an entire set of measurements, which cannot be revealed, that is called systematic errors. It may arise because of instrumental defect or experimental bias. Whereas the random errors caused by disturbances to the equipment, fluctuating in the experiments, and lack of measuring system sensitivity. We will go in detail and discuss one by one. As I have told, no measurement is exact. That is, all physical measurements are subject to various types of errors. But it is important to reduce the effect of errors to a minimum. To reduce the error to minimum, we should know how or what are the sources of errors. Then only we can minimize the errors. Error can be defined as the difference between true value and the measured value. See, the true value is 19.7, but the measured value 19.82 or 19.62. We can broadly classify the errors into various categories as we are seeing: gross errors, measurement errors, and blunder error. Measurement errors, we are concentrating on measurement errors, which can be classified into systematic and random errors. Further classification of systematic errors goes like this: instrumental error, environmental error, observational error, and theoretical errors. First we will see gross error. Gross error is nothing but the mistake by human. The operator or the machine person may make some mistakes. That is called human mistakes. Like careless reading, while recording by mistake he may record incorrect reading, improper application of instrument, during calculation some error can be occurred. These are called gross errors. Blunder, mistakes or blunders. Blunder, mistake, that is by carelessness, poor judgment, incompetence. Okay, now we will come to the third, systematic errors. These are divided into subcategories like calibration error, ambient, loading, error caused by defective equipment, and avoidable errors. Systematic errors are avoidable errors, whereas random errors are unavoidable errors. The instrumental error, it may be due to design or construction. The accuracy is limited. Improper selection of instrument. See, for measuring 0.5 mm, if you are choosing the micrometer of 1 to 50 mm range, which will not give correct. It is not easier also. So we have to choose 0 to 3 mm. That range should be within the limit. That is improper selection of instrument, poor maintenance. If you are using slip gauge and other things, we have to maintain it properly. Friction, wear, slips, etc. Vibration while measuring or while machining. Incorrect fitting to scale, non-uniform division of scale, bent pointers. The bent pointers, if it is a lengthy, we have to have two supporting. If we are going to measure the lengthy object, we have to support that lengthy specimen at the two pivots in such a way that 0.577 into L, the pivot, the distance between two pivots or two supporting should be of 0.577 into overall length of the specimen. Then only the end will be parallel to the measuring instrument. So that calculation we have to consider. That is called important measuring technique. Environmental errors, it may be due to temperature, pressure, humidity, or electrostatic field. Buoyant effect of the wind causes errors in precise measurement of weights by pan balance. These errors, environmental errors, may be avoided by using the instrument in an air-conditioned room, providing sealing certain components in the instrument, calibration of instrument under local atmospheric conditions. And now look at this micrometer. If you are not taking proper matching of the scale, that is minor scale and major, it may lead to error, that is parallax error, vision error. Fitness and straightness of the pointer, construction of the scale, efficiency of the skill of the observer. These are some causes for errors. Theoretical errors are caused by simplification of the model and system. For example, a theory states that the temperature of the system surrounding will not change the readings taken when it actually does. Then this factor will begin a source of error in measurement. The temperature will also play a role in measuring. Alignment error, that is cosine error. If we are measuring inclined line, that will be different, and if you are measuring the straight line with the parallel, that will give a different reading. So that alignment error we have to take care. Calibration error, if it is not properly calibrated to the scale, then it will give error. Stylus pressure error, it is a very sensitive element of the interferometer or any other optical measuring device. We should not give more pressure or too small or too high pressure. It should just in CMM, just we have to bring it closer to the object. The sound will come, we have to touch upon, that is we have to touch the object. That is called stylus pressure error. If you put more error, then reading will be error, erratic error will be getting. Last one is random errors. This can be predicted, such as noise and fatigue in the working persons. These errors may be positive or negative, but it will form the normal distribution curve. The error will be of uniform, negative error and positive error will be of uniform. It can be minimized by taking average readings. In the last slide, we will discuss the difference between systematic and random errors. The systematic errors are predictable, random errors are non-predictable. It can be determined and reduced if properly analyzed, whereas random errors are variable, cannot be eliminated. Systematic errors can be determined by comparison with the standards. Random errors have to be determined through statistical analysis. Example for systematic error, improper calibration. Random error, temperature variations. Yes, we'll wind up this session. Thank you for watching.